Today we are going to cover section 3. It will cover proofs with parallel lines. Typically, we are told that M and N are parallel, therefore find the value of x. This time we're going to do it backwards. We're going to find the value of x that would make M and N parallel. These are consecutive exterior angles. Consecutive exterior angles are supplementary. So 4 times the value of x plus 5 added to the 72 degrees should give us 180 degrees. Distribute the 4. We get 4x plus 20 plus 72 is 180. Now we'll combine like terms to get 92. And now I can solve for x. Subtract 92 from both sides. 4x is 88. Divide by 4. X is 22. Now, it asks you to state the theorem that you used. Because these are consecutive exterior angles, we use the consecutive exterior angle theorem. We will say we used the consecutive exterior angles theorem. Okay. For numbers 1 through 4, we need to find the value of x that makes the two lines parallel and then state the theorem that you used. So here's number 1. Go ahead and work that out. On to number 2. You can pause and work this one out. Number 3. Go ahead and pause. And lastly, number 4. Go ahead and pause and work that one. Okay. So we've done numbers 1 through 4. You can verify your answers back in the Google Classroom. For 5 through 10, we're going to talk about whether there is enough information to prove that lines are parallel or not. And if there is enough information, we need to state which theorem we used. Okay. If we look at this, we can see that these are corresponding angles. They are corresponding angles on M and N, so it gives us information about both lines. From this, we can say yes, there's enough information to conclude that they would be parallel, and we would use the corresponding angles theorem. Angles theorem. Okay? Number 2, or number 6. This would be an example where there is not enough information. These are vertical angles that are indicated. So specifically here, we're told some information about line M. Both of these angles relate to line M, but there's nothing going on with line N. That is a big indication that we just don't have enough information. So we will say no or not enough info. Okay. I'm going to click through and you can pause. On we go. Pause. Okay. Pause. Here, we will just go with M and N. Okay, now pause. And on to the last one. Again, M and N. Pause. Okay, so we worked through those. The transitive property of parallel lines says that if two lines are parallel to the same line, then they are something to each other. So if we have lines A, B, and C, if A is parallel to B, and B is parallel to C, then it follows that A would also be parallel to C. So they would be parallel. Okay? Now, you can go ahead, you can try to work this out if you want. I'm not going to work through this. If you want to work it out, you can pause now. If not, we will move on ahead. Okay? This is how we started. I'm just going to kind of talk us through it. Step 1. Where I've written a 1, we first start by solving for x. This would make P and Q parallel. Where I write the 2, we would solve using our x we just got and then solve for y. This would make Q and R parallel. Lastly, where I put the 3, we will set those supplementary because they're a linear pair, and that would give us C. That helps us prove that P is parallel to Q and Q is parallel to R. So for A. And then for B, I'm going to let you try to figure that one out. But you can solve for X, Y, and Z using the information that we already have. And you should be able to work this out pretty easily. If you want, you can pause. Otherwise, we're going to move on ahead. Okay. We did a check for understanding activity in class. This was to prepare you for the quiz. This is the homework for section 3. If, as you're working through some of these problems, if you have any questions or you want to check your answer, you can do that within the Google Classroom. Thank you.